Saxon Algebra 2, Lesson 107. Here's a fun little algebra word problem. I know, haven't we done a million of these already this year? Yes. Are we going to do it? Make it 1,000,001? Yes. Before we begin, these have a fun little twist. They feel a little different and they have nothing to do with distances or rates. So let's just take a minute and celebrate that happy turn of events. Let's review the difference between the words number and numeral. Okay? Numeral means the symbols themselves. All right? And you learned a long time ago how to make those shapes, right? And you learned to put them in a certain order. But just like the letters of the alphabet, you have to learn what they mean, right? The symbols themselves don't have any meaning. It's only when you learn, oh, this is 1 and it stands for like that many fingers, right? And this is 3 and it stands for that many markers. You had to learn how to associate value with these symbols before you understood what a number is. A number is a symbol with an understood value. Okay, so I just illustrated a couple of them for you with my finger and my markers. But here's another example of how a numeral and a number are different. If I just write down the number 2, that is a numeral, 2, but you also understand, okay, that's 2, that represents 2, right? But if I do this, I have not changed this numeral. The symbol is exactly the same. But by writing these 2 additional zeros, I have significantly changed the value of this number, haven't I? But only because you understand about place value, right? You understand, I just changed that from a 2 into a 200, and it represents many more times what it originally did. Even though I didn't change, it's kind of weird when you think about how smart we are, right? I didn't change that at all. That represents that. But by writing this next to it, I just changed that number quite a bit. And I can do the same thing if I put the same 2 there, and if I go like this. Now, again, it's the same 2, but now I changed the number in a very different way, didn't I? That's the difference between a numeral and a number. A number is a symbol with an understood value, okay? This is going to be somewhat important in these word problems that we're going to do. Okay, and you probably did this back in the day. You probably did little problems that look like this. You'd see, oh, this is 23. The 2 represents 2 in the tens place, so it's 2 times 10. And the 3 is in the ones place, so that's 3 times 1, right? Do you remember doing that? When we want to set up a variable and talk about the digits, we can put a T for the unit in the tens place. And instead of calling them units, we're calling them ones places. Do you see how we can set up variables to do it that way? Now, what if I wanted to take the numerals in this number and have them trade places? That means I'm going to put the u, the variable for u, I'm going to put that into the tens place. And the variable that I was using for the tens, I'm going to now put in the ones place. And now, I can switch them. This is a little confusing. This is a switch. This is a little weird because we're used to always associating U with units and T with tens place, but we could move the letters around, couldn't we? And in these story problems, that's what we're going to do. Let's look. Enough preambles. I get bored with those. The sum of the digits in a 2-digit counting number is 11. A 2-digit counting number. The sum of the digits is 11. So what we're going to do is we're going to call our number T TU, that's our original number, because we're going to change it in just a minute. Okay, and the sum of the digits is 11. So we can say that again, what we're doing here is we're talking more about the symbols and their primary values. We're not talking about their place values. We're not doing this. We're just saying take that digit plus that digit, they'll equal 11. All right? If the digits are reversed, that's what I was talking about before. If the digits are reversed, we took the digit that was in the units place and we popped it into the tens place, and we took the digit that was in the tens place and we popped it into the units. Oh, that's so weird. If the digits are reversed, the new number is greater than the old number. If we reverse the digits, the value of the new number, okay, the value of the new number, let's just do this. And this is what I did up here. The value of the original number is 10 times t plus the units times 1. We don't have to write that, right? This is a shorthand way of writing this. Agreed? T times 10, that's 10t, plus u times 1, that's just u. We don't have to times it by 1. Multiply it. Okay, now with the reverse digits, we'll do it the exact opposite way. It'll be 10 times u plus t, which is what I did here, right? U times 10 plus t times 1, same difference, okay? So now we're saying that if the digits are reversed, the new number is greater than the original number, okay? The new number, 10t plus, oh, I'm sorry, I did it wrong. 10u plus t is greater than the original number, 10t plus u, this is u. And the balancing number is 27. The new number is 27 greater than the original number. So I'm going to add 27 here, and that will change it into an equation. What was the original number? So we're going to solve this, okay? Now, spoilers, I'm going to just copy this. I said spoilers, and then I stopped. The spoiler is that we can clean up like terms in this equation before we go any further, all right? So let's do that. Let's clean this up. And the way I would do that is to leave the 27 here, and let's subtract 10t from both sides. And let's subtract u from both sides. 9u minus 9t equals 27. How do you like that? Looks so much better, right? John doesn't do that, and I've never understood why he doesn't. It's so much better that way. Now, let's rearrange this guy and get, let's say, t by itself. It would be t equals 11 minus u. We can plug that in here. Oh, I'm sorry. I plugged it into the wrong one. It's t equals. So it's 9u minus 9 times that thing. Right? I substituted it into the wrong letter. Or I tried to. I caught myself. All right, you guys didn't even have to scream and pull your hair out when I made a complete mistake. Okay, 9u minus 99 plus 9u equals 27. Okay, I say something looks wrong here. Oh, that's because I'm solving for u. Okay, never mind. Let's add together the two u's. So I get 18u, and then we're going to add 99 to both sides. That's messy. 18u equals 126. Divide by 18, and I'm pretty sure that's 7. Let's see. 18 times 7. The reason I'm guessing that is because I know 8 times 7 is 56. That will give me the 6 that I want in the ones place. That's how I guessed that. Yes, it does work out. So u equals 7. And now, just like any other system of equation problem, I go back and see, how do I solve for the other one? T must be 4, right? Because they have to add up to 11. Check. So that means the original number is 47. Yay, I got it right. I was getting nervous in through here because it was looking like my answer was going to be different than John's, but I solved for u first and he solved for t first. So that's why he wasn't, I was saying, oh, I'm going to be ending up with 7, and John doesn't say 7. Well, that's because he was saying 4. He was saying the other part of the problem. Okay, beautiful, right? Straightforward, to the point. This whole setting it up thing is weird. But if you can just get this understanding into your brain, this is the secret to understanding these whole problems. And you can even kind of like memorize this. You can write this in your cover, right? The value of the original number is 10 times the digit in the tens place plus the units place. And then when we reverse it, then what used to be in the units place is now in the tens place. That's when we multiply by 10. What was in the tens place is now in the units place, so we multiply it by 1/do nothing. Okay? That's what you need to understand to do these problems. All right, we have one more to do, but you know what? My battery is getting near the end, so let me run go get my charger. And you can just stare out the window or think about your life, and I'll be right back. Okay, keep looking. I'm almost ready. Good girl, Grace, not you. You just keep lying there. It's so annoying because the little lightning bolt doesn't show in record mode. So I have to trust that it's working. Charging. Okay, ready? We have one more of these to do. All right. The sum of the digits of a 2-digit counting number was 9. The first one's always easy. It has nothing to do with their place value. We're talking about just the little numerals and not, well, we're talking about I guess we're talking about the primary value, but we're not talking about the place value. When the digits were reversed, okay, so let's just write the original was 10t plus u and the reversed is 10u plus t. So when the digits were reversed, the new number, the reverse number, 10u plus t, was less than the original number. When the digits were reversed, the new number was less than the original number. Okay? It was 45 less. So this is the bigger side, so I have to subtract 45 in order to get this to work, right? I always like to make my adjustment here because I have room to add on. I don't want to rewrite it. Okay, beautiful. Now what do? This is our system, and I want to clean this up before I substitute this in. So let's do that. Let's subtract the 10t, and let's subtract the u. And it's pretty much always going to work out like this, you guys. This cancels, and I get 9u minus 9t equals minus 45. And then we go up here, and I like to just bump the u over, so I get t equals 9 minus u. I plug it in right there. 9u, whoops, minus 9 times 9 minus u, I feel like I'm talking in circles, equals minus 45. Right? I substituted this into that t. There it is. That was me getting excited about those parentheses and making them too soon. Okay? Next, 9u minus 81 plus 9u equals minus 45. Add these two guys together, and let's add 81 to both sides. Swim that little fishy. 18u, right, those two, equals, what's the difference between 45 and 81? I'm going to say 36. Divide both sides by 18, and we get u equals 2. So t, they have to add up to 9, so t must be 7, right? And so our number, our original number, which is usually what they ask, let's see. It says, what was the original number? Original number is 72. Yay, that's right. Cool, right? I will say, if you look at the solutions manual, I don't like what John does. He does not clean this up before he substitutes. So he substitutes into this mess, which just creates a lot more drama because you have to substitute twice and you have to distribute twice and you end up with a boatload of terms. You know me, I always like to make my numbers smaller before I make them bigger. And that is a perfect example of that. Okay, original number 72. Yay! I won't pretend that these are easy, but I will say compared to a lot of the word problems we've done, they are less headache-inducing, so I hope they make sense to you. I'll ask you on our chat this week, I'll ask you about these. Remind me if I forget. I won't test you on them, but I will ask you about them. Okay, thank you, bye.